Hello, everybody, and welcome to this video where I'm going to go ahead and talk about the resources that you're going to have at your disposal to help you succeed in this class. So the very first one that we should all obviously be paying attention to are the videos that I will be releasing throughout the course. Actually, they will all already be up on my YouTube page. All you have to do is click them and watch them. Now, how should you treat these videos? Well, remember that if this was a typical class, you would be spending probably in the summer 3 hours per class, 2 classes per week, 6 hours sitting, listening, talking, and all that stuff. And these videos are broken down into more manageable bite-sized pieces, but you'll see there's a lesson 0, a lesson 1, a lesson 2, right? Some are shorter, some are longer, and they're meant for you to be able to kind of skip around. I've tried to title them with chapters for the little bits of relevant information that are in them. That way you can go back and study them. But you should watch the videos in their entirety. You should sit down and have time blocked out in your schedule to sit and really watch the video, listen to what I'm saying, because a lot of what I am going to be trying to teach you in this class focuses on conceptual understandings of these, these complicated topics. And so I will talk a lot. And so if you skip around and you're like, oh, this is all he wrote in the last 2 minutes, I'd say you're missing out on a lot because I talk a lot while I do these videos. So your first resource you should use is to watch these videos. And I'm going to try and keep the totality of them less than 6 hours in length, right? It should be less than 6 hours. So like for this first lesson, there's going to be, or for this first week, there should only be actually one extra video. And so there's going to be maybe, I don't know, an hour to an hour and a half worth of stuff for you to watch for this first week. And that should cover all the content that I'm going to try and talk about. But obviously, that's not going to be the only resource, right? These videos are to provide a conceptual understanding, a visual understanding to orally tell you all where I'm trying to go with my videos. But the second resource that you guys should use, let me pull it up here real quick. The second resource that we should use is going to be the textbook, which almost makes too much sense. But the textbook has everything in it that you need to know about what we're going to be learning. So in the class calendar, it says what we're learning. It says which sections in the textbook that we are going to be covering them. And if you go through the textbook, it's going to have a whole bunch of things that maybe I might not have gone through in the videos. It's going to have technical definitions. It's going to maybe elaborate a little deeper onto some of the concepts that I'm talking about in my videos. So the videos will be kind of a more surface level. This is the idea. This is how we do an example sort of thing. But as you can see, the textbook has some really nice visual examples. It has really rigorous definitions. And I will go through some of these as well in my videos. But if you need that extra bit of support, you want some extra visuals, you want to do some practice examples, you want to see maybe different ways of writing what it is that I talked about in my videos, right? Sometimes I'll reference theorems and I'll say, oh, this theorem is in the textbook. It's going to be in the textbook in the section that this is about. So 15.1 double integrals is where you would find it. So you should read the textbook. And I know reading a textbook isn't exciting, but this is a summer course, which means there is a lot more kind of self-sustaining behavior you're going to have to engage in as a student. So let's talk about some other things that we'll have. So beyond the textbook, beyond the videos, what other resources do we have? Well, there are, of course, other videos, right? There's other videos. There's the Chem Tutor, a very good resource on YouTube for learning about things. A lot of people like his videos. There's also my personal favorite, this gentleman, Dr. Trefor, basically always has really good examples and really good intuitive ideas and drawings that explain what's going on. And I really enjoy his videos. So if you're ever getting stuck, it might be a good idea to go on Google and look up some examples or things like that as well. And of course, never fails us, Khan Academy is also an excellent resource to use because they often have written segments, kind of mini lectures, if you will. They've embedded all of their own videos. They also have other videos which have worked out problems, visual interpretations. You might recognize that this looks very similar to stuff that I have done as well. So there are a whole bunch of resources at your disposal to really help you understand the material that we're going to be covering. Videos are excellent resources, but maybe some of you like to do more reading. So Paul's online notes is an excellent resource for this. Visuals, technical definitions, all that good stuff. Pretty digestible, talks to you as if you were sitting and having a conversation with this person. So really, really good resource. Oftentimes has worked out examples. The sections tend to go one after the other. So you'll see from the previous section, we go to section 15.2. Now it's on iterated integrals, and it has problems. It shows you have solutions. It tells you how you go about doing this. And it doesn't just give you the answer. It gives you worked out step-by-step solutions, which is very nice. There's also this wonderful resource called Stack Exchange. So if you go onto stackexchange.com, or really you Google any question, right? Actually, to get to this page, I literally typed in double integrals Stack Exchange, and I clicked on the first result, but you can obviously click on whichever one. But I clicked on the first one and it took me here. This is a question that someone had. If you scroll down, this is an answer someone gave. It's the most popular answer. It got voted for. It's got visuals, things like that. So sometimes if you're really having trouble, you can go and look for other people's explanations here. There is also another textbook for this class. There's an online textbook. You can find the link for it on the home page of the Canvas course, which is really nice. So there's a second textbook if you want to get another opinion, another author's way of describing certain things. This is the second textbook for the class, and it's really good at having a whole bunch of worked out examples, different visuals, different aids. But look at all these examples with solutions all built in. It's really, really nice for you to go ahead and use to supplement your learning. So you might be asking the question, Dylan, why do I need all of these resources? Well, because when it comes to doing the homework, when it comes to completing your homework, some of which will be online like this, but when it comes to completing your homework, I probably will not in my videos go over how to do each of these exactly verbatim, word for word, right? What the homework will do is it's going to stretch kind of what you know and what you've learned from those videos, and really kind of pick at your brains and say, do I know really what is going on? Can I transfer what I've just learned? And so, for instance, this is kind of what a typical homework assignment is going to look like. There's going to be some online problems. You're going to have some textbook problems, which come directly from the textbook. You might have more word problems, which I will write out. And you notice, this question, for instance, last time I taught this class really kind of stumped people. They were like, we never talked about energy release and total energy release and stuff. And we kind of did, but not in a very straightforward way. So this class really, really relies on your ability to infer and make jumps between kind of what is being shown in the videos and how to connect it to other ideas. You're also going to have review problems from the textbook, but we'll talk about those in another video. So the whole point of me telling you all this is that there are a lot of resources and you will be expected to really take advantage of all of them. If you don't understand something I said in a video, or if you're looking ahead at the homework and you really don't understand how to solve a certain problem, what you really should do is you can email me and say, where should I go? But you can come to any one of those websites that we were just going over. You can watch videos, you can read stuff from Khan Academy. You can read stuff from Paul's online notes, go on a Stack Exchange, whatever you want, go on the other textbook, and that should help you get through it. And you should be doing all this by taking some sort of notes, whether it's in a binder or maybe you take video notes or whatever, but you should take notes and really annotate your notes as you go. So let's talk about some maybe other resources to help you actually solve stuff. So one of my favorite for 3D calculus is this program called Geogebra, and Geogebra 3D specifically. And what it allows you to do is it allows you to plot 3D shapes here. And so you can do that just like you would in Desmos. You kind of put your equation up here in the left corner. I like to go to settings and I really like to label my axes. So I will go here and label it with an X and and then I will label my y1 with a y and z with a z, and it labels the axes for you so you don't get kind of turned around when you're looking at these shapes. But this is going to be super important because one of the most important skills to have in this class is really to be able to sketch these shapes. When you do a quiz, when you do a project, when you do your final, whatever it is, you really need to be able to understand, or when you're doing your homework, what these shapes look like so you can understand how to go about solving certain problems. I can't really get too deep in details yet because we haven't really learned anything in this class yet, but this is an important tool to have. Now, I would use this as a supplement. Okay, you should know just by looking at this equation, this is an ellipsoid. You should know that if I do x plus 2y plus z equals 3, that you're going to get a plane, right? These are very fundamental shapes from Calculus 3 that we should know what they look like. You should also know how to go about figuring out what the intersection of these two shapes are, right? You set things equal to each other just like you did in, well, way back in Algebra 1, essentially. How do you find the intersection between two lines? You set them equal to each other, get a point. So you can also use Desmos, right? Let's say, for instance, you're doing the traces, and for instance, you want to really figure out how to sketch this thing, right? And you don't know what it's going to look like. So remember that from Calculus 3, your last calculus class, you should have learned how to sketch the traces of 3D objects. Okay, and so if you don't know what that means basically you kind of just take a head-on look. So maybe you set y equal to 0 or x equal to 0 or z equal to 0, and you look and you say, what shapes am I going to get if I look at this? And I'll have another video on how to do that later on as well. But if you forgot and you're like, I don't really know what this looks like, if I set z equal to 0, Geogebra won't do it for you. It'll kind of do it, but it looks like a cylinder sort of, or an ellipse. And so you can go to Desmos and do it here, but you do indeed get that ellipse shape. Now let's talk a resource that you have for actually solving problems. A lot of this class, pretty much in its entirety, is all about solving integrals. And I know this is an online class, and so I'm just going to go ahead and point you to a resource. There's this wonderful resource called Symbolab, and it allows you to do things, amazing things that really kind of keep you from thinking a lot on your own. But you can solve really awesome questions like double integrals, like so. You just click go, right? And it will give you a solution. You click show steps. Now you do have to pay for the service if you want to see all of the steps here. And I hope that none of you need to pay for those, because this already does a good job of getting you, this kind of is like, oh, what is the answer? And it kind of gives you a rough idea, like some intermediary steps to help you along the way. Now, again, I know this is an online class, and I know that there are multiple resources out there that allow you to solve integrals. So please listen to me when I tell you that this class, I will be grading your work very heavily. And I will be much more interested in your conceptual approach to these problems than I will be in the actual answer itself. That's the first thing. The second part of the, okay, actually, so what does that mean? That means I'm more interested in how did you set this up? Were you given a word problem? How did you set this up? How did you come up with this? Okay, that is what I'm more interested in. How did you get there? That is going to be worth a lot of points. The second, probably most important thing in this class has to do with, how you're going to be graded. And the idea is that, like I kind of just mentioned, I don't really care about this answer. I care more about your ability to set this up and, get your problem kind of situated. Now, I understand that there are many more resources in this. Stack Exchange sometimes has fully worked out solutions. Symbolab, if you pay for the service, will solve all of these. There's Chegg, there's Quizlet, there are endless online resources available to solve almost every single problem that you're going to get in this class. Please hear me very clearly when I tell you all that I am subscribed to all of those services, and I check them and their solutions that are available to the problems that I will be assigning you in class. So I know when you are copying directly from an online resource versus authentic student work. You might be like, well, Dylan, how could you tell? What if that's the right answer? Because there is a clear difference between the work of a student who is learning Calculus 4 versus the work of a mathematical professional or a computer program that has been either been doing this for years and years and years, or is following a very rigorous set of steps that may or may not use techniques that I am trying to teach in the class. Now, your defense might be, well, can't we learn other techniques than the one that you're teaching us? Sure, but typically I would argue that most students are focused on learning the new material, that they aren't also, on top of learning and reading and watching videos and doing all that, going and learning completely convoluted or new techniques that have never been taught to them in their life that may be more advanced. And so it's more often than not an indicator that you're not doing your own work. So please trust me when I tell you, when I assign you online homework problems, I don't care. I'm not looking at your final answer. I will be looking through your work meticulously and comparing it to online solutions that exist, things like that. So how do you avoid that problem? The idea is you can use this as a resource, okay? Use Symbolab as a resource to maybe check that your setup was correct. So if you were doing a word problem and then you thought that this was it and you did the work by hand and you got an answer, I would then go on to Symbolab and check that you actually got the right answer. And if this answer doesn't match yours, I would go back and kind of try and figure out where your mistake was. Use it to help supplement your learning. Do not use it to take the place of your own work. I have no problem failing a student for plagiarism of any sort. So I want you all to succeed. And more importantly, I would like you all to come away with this class understanding really the concepts of things that have been taught to you in this class. So please do yourself a favor. Don't just focus on the grade. You're going to get an A. I promise you, you will get an A in this class if you're doing the work on your own, if you're asking questions. And actually, that should lead me to our last resource, which is going to be on Canvas. Now, this is not published for you all to see it, but eventually you will see these discussions, and you can go to a discussion like homework 1, and you can post questions here. Right? You can post questions. You can click this little button here and you could put in entire equations, right? If you know how to code in LaTeX, you can click this and code it yourself, but you can put in operators, you can put in Greek symbols, you can put in little arrows, whatever it is you need, and you can type in mathematical questions and your peers and myself will see them and answer them. And this is probably one of the best resources available to you, which is using this space to, if you're watching a video and you have a question, just boom, post a question in the discussion and I will answer it relatively quickly, or your peers will answer it, and just get your questions answered as soon as possible, just like you were in a class, right? You would not sit in a classroom and have questions and then wait all the way to the end of class to ask them. You would try and ask questions as the stuff is being taught to you. I strongly suggest that you use this tool, and if we've done it correctly, typically this thread will have like 15 or 20 or 25 or 30 comments and questions throughout it that students have asked. And so I strongly recommend that you do the same. Okay, so that's going to do it for resources. There are plenty of other resources out there, but these are the resources I would suggest that you kind of familiarize yourself with and kind of build the expectation that beyond watching my videos that you are going to need to kind of use and rely on these alternate resources. And if you're having trouble figuring out exactly which one to follow, you can post in the discussion, get it answered, and then I can also post like, oh, you should watch this video or read this or check out this part in the textbook, and then your classmates can see that as well. So thanks for checking out this video, and I'll see you all in the next one.